Okay. Welcome, everyone. I'm really pleased. Guest lecturer, Ray Richardson, my former boss at Similarity, and shop. Ray's been a Prolog programmer for, gosh, how long?
About 35 years.
Long time. And is extremely knowledgeable. So,
Right. Should I go ahead and put the presentation up now?
yeah,
Because
sure.
it has 2 slides on the Singularity.
Yep.
Uh, okay. Can you see
Yep, we're good.
presentation?
We're good.
Okay. Well, what you're really interested in is who am I? And I'm Ray Richardson, as Annie said, and I'm the Chief Technology Officer of Similarity, Inc. And as I mentioned, I've been programming in Prolog since sometime in the mid-1980s. And I have been programming in Prolog commercially, both in academia and with commercial companies. Some of those companies are listed here, Wind River and Intel being the latest place I was at before Similarity. And I included something here about my Prolog moment. And this is the only line of code anybody's ever going to see in this presentation. But I picked up a book on Prolog in the early 1980s. And I had been programming for a few years at that point. And I was familiar with languages like BASIC and Fortran and Pascal of the time. And I saw you had to implement your own list processing in early Prolog. And I saw an example implementation of member, which I have included here. Now, everybody should have seen this. But when I realized you could write a predicate which recursively found whether or not an element was a member of a list and returned all such elements as members of the list if necessary, could be written in one line of code, I was intrigued and I set about learning Prolog. My fascination with that line of code has never stopped. Whenever I find someone who doesn't know anything about Prolog, I show them this line of code as to why you should use Prolog. Now, we'll also talk about why you shouldn't use Prolog, but this conciseness, this ability to write some kinds of things very efficiently and very effectively is the key notion of Prolog. It's also declarative. You can read this line of code as H is a member of a list if H is the first element of the list, or if it's contained in the rest of the list. And that simple statement is very simply expressible in Prolog. Everybody has this kind of moment. Every Prolog programmer has this kind of moment. This thing where you realized Prolog could really solve your problems. And one of the things that we need to do as Prolog evangelists is help other people have this moment. But before we go there, what are the kinds of things we do at Similarity with Prolog? We're an AI company that's focused on anomaly detection and satellite image analysis. And we detect anomalies in satellite images and in time series. And we also have software which identifies events and objects using anomaly detection and expert systems. And as you can imagine, those expert systems are all implemented in Prolog. But we use a number of programming languages. We use Prolog, we use Java, we use Python and Ruby, often using versions of Python and Ruby that run on the JVM. And I'll talk more about integrating Prolog with the JVM and some of the problems and things that go along with that on another slide. But kind of the basic message here is that we all know Prolog is good for AI kinds of things. We all know Prolog is good for expert systems, but we also use Prolog in embedded situations in other programs to provide this kind of inference engine functionality that when you don't have it, we often don't even build things. And you will find that a lot of programs are built the way they are because the programming language that it was written in shaped the way they did it. And when you're letting Prolog shape how you do things, you can do some things that you're just not going to do any other way. Besides that, people don't like Prolog. And whenever you mention Prolog to people, they come up with a number of reasons why it isn't used. And I have a friend and business associate. I was co-CTO at Wind River with him, and I have been programming on various projects with him for nearly 20 years. And I mentioned about 10 years ago that he should learn Prolog, and his answer was enlightening. He said, "Why would I do that? All you can write with that is a family tree program." And I laughed, and it was kind of ha-ha only seriously. And every Prolog book you open up, if you ever go to learn Prolog, in that first chapter is going to be the damn family tree. And if I ever write a Prolog programming book, it's not going to have any family tree in it, because I realized when people see a couple of Prolog books, they're like, why does everybody always use the same example? Why does everyone always use the same example? Is that all it can do? Now, we all know that's not all it can do. Prolog is a general purpose programming language which any program can be written in. It's Turing complete. But it has a number of reasons why it isn't used. And these are real reasons. These aren't imagined reasons. One, Prolog is difficult to learn for experienced programmers. And the reason why is, I taught a class some years ago at the University of West Florida in programming in Prolog. And the first day I would tell the students, forget everything about programming. Prolog has no variables. It has no functions. It has no procedures. And once you understand that, you're capable of learning Prolog. But you can't equate a Prolog predicate to a function or a procedure in another language. And variables in Prolog are much more like mathematical variables or logical variables, and less like the variables of C or Java or Python or Ruby. And so in the many years that I have been programming in Prolog in the commercial world, I have found that the more experienced the programmer is, the harder a time they have learning Prolog, and the more they try to make Prolog fit into other paradigms like imperative or object-oriented programming. This is simply because Prolog is so different from other programming languages. And this is something that classes like this are designed to fix. That you really need to have an academic environment where someone points out what you're doing. Prolog is difficult to learn from a tutorial online. And I've learned a number of programming languages from reading a book or doing a tutorial online. But Prolog, if you already program, is difficult to do that because you have preconceived ideas that get in the way. Secondly, Prolog is difficult to extend with other languages. And there's a number of reasons for this, but it largely has to do with the fact that, just like I said before, Prolog has no procedures, functions, or variables. The very basics of other programming languages are difficult to reify into Prolog. Now, it's done and people do it, so it's not impossible, but it can be awkward, and it's another thing you have to learn in order to get anything done. And we'll get to why that is in another second. And third, Prolog can be inefficient in terms of time and space. Prolog programs are many times slower than an equivalent program written in Java. It will also use more space to store its data structures, typically, than an implementation in Java or any other program imperative or object-oriented programming language. Now, there's a reason for that, and you get benefit from that, again, which we'll cover in a minute. But this is a common first criticism, and you have to be prepared. If you're evangelizing Prolog in a commercial environment, you have to be prepared for people to say, well, it's 10 times slower than what we're using. What is that? What do we do? And then there's some practical reasons, and by that I mean reasons that have to do with the implementations of Prolog more so than the language itself. And the main one is that Prolog implementations have historically been aimed at academia. And that is that they have been designed to have results and not worried much about things like user interface or whether it integrated with your favorite database or so forth. That these academic implementations have been designed to have all these kinds of academic things in it, like constraint handling rules or constraint logic programming or things like this, which are very popular in academia, but haven't really broken out into the commercial world. And by the way, at Similarity, we don't use either of those features of SWI-Prolog. And then the secondly, some algorithms are difficult to implement in Prolog. Now, in a minute, we'll get into that. Some algorithms are difficult to implement not in Prolog, but this interacts with the fact that Prolog is difficult to extend with other languages. That if some language algorithms are difficult to implement in Prolog, well, you would implement them in some language that it can be easy to implement, and it can be difficult to glue those pieces together. And the third part is that there is no universal connectivity to databases or any other software package. And the reason for this is that no one writes a Prolog interface to their software. That if you want to use, say, Apache Kafka, there's no Prolog interface. You have to write it yourself. And that's extra work that people don't want to do. This is particularly exacerbated by the fact that Prolog implementations differ drastically. This presentation doesn't talk about any particular implementation of Prolog. At Similarity, we use two implementations of Prolog. We use SWI-Prolog, as Annie mentioned earlier, and we also use PDTJuly when we have to embed things into the JVM. But those two Prolog implementations differ drastically, and their source code is not compatible with one another. And in fact, it is very difficult to write modern Prolog software that doesn't use these extensions that each Prolog implementation provides, which are different from the others. And so portability is a problem which has not yet been solved and is difficult. But then there's why you should use Prolog. And the thing is, we talked a minute ago about how there are some things that are difficult to implement in Prolog. Well, there are some things that are way easier to implement in Prolog. And number one among those things is parsing. And the reason parsing is so easy to do in Prolog is because of definite clause grammars. And when you get skilled with using DCGs, you can construct a small language in minutes instead of days or weeks. And what this means is you'll do it instead of not doing it. So implementing little languages for things like configuration, or even building big languages for things like a Rete-based forward chaining rule interpreter, DCGs allow you to handle the language component of that, taking the language and turning it into an abstract syntax tree very easily and in a way that's native to the Prolog programmer. When you do this in C or C++ or Java or any other programming language, you have to use special tools which generate some code or libraries that are difficult to use or aren't integrated with the language. And so people just don't do it. And so this construction of parsing things is very important. And to give you an idea of how important this is, I was writing some code immediately before this class, and I was writing DCGs to do parsing in Prolog. And one of the things that's important for our satellite image analysis is an expert system that can figure out when the satellite image was taken. Turns out this metadata is not in the satellite image. And it uses a wide variety of rules for doing this, but it's an expert system that that can figure out when the satellite image was taken. We add facilities to it all the time, and today we implemented a new data source that has a different source of where this timestamp comes from. And so in about 20 minutes, I wrote a parser that parses the source of DCGs. It works, and now it's running fine. Total implementation time, 30 minutes. So if parsing is your problem, DCGs are almost certainly your answer. Another component is Hummel Iconicity. And Hummel Iconicity is kind of all the rage right now in functional programming. And all of its advantages in functional programming also apply to Prolog. Hummel Iconicity is when data and code are in the same format. Homo iconic means having the same representation, or it comes from the word for the same representation in Greek. And it's when data and code are represented the same way. And this, in Prolog and most other Homo iconic languages, allows data to be called. It is an extremely effective method of structuring programs, and allows features like lambdas or closures to be implemented trivially in standard Prolog. There are a number of implementations of lambda libraries out there for Prolog. You can write one in half an hour. And this is a feature which typically must be included with a programming language for you to be able to use it. Virtually all other programming languages that have lambdas or closures had to implement them as a component of the programming language, whereas in Prolog, because of Homo Iconicity, it's just a part of the language, and if you need to use it, it's easy to implement. I'll let Annie get into how you use this to construct programs in a later class. Yes, Annie.
No, I was going to add, even compared to a language, function body and do something with it. But that's a pretty routine thing to do with Prolog.
Exactly, and that's the second bullet point, is that Prolog allows self-modifying code. And you know, in other programming language worlds, people will tell you never write self-modifying code. But in Prolog, asserting predicates into the database and retracting them from the database, or clausing them out of the database, modifying them, retracting and asserting them, is something that is fairly commonly done. And so Prolog not only allows self-modifying code, the database structure of Prolog allows a means for it to not be scary and for it to be able to be used in ways that represent reasonable software engineering practice. Now, these two things add up to something, that these two things right here are why Prolog is difficult to learn. The reason why Prolog is difficult to learn is because most programmers are not accustomed to Homo Iconicity, and they have been told all their lives not to write self-modifying code. The third reason why Prolog is way better than other languages is the declarative syntax. Now, SQL has declarative syntax, and there are a few other programming languages with declarative syntax, some of which are closely related to Prolog, like Mercury. Programming languages that have a declarative syntax are great for representing relationships. Now, this is why everybody writes that family tree program, because the simplest relationship humans understand are the family relationships. But really, we need to get off that and represent some other kind of relationship, so people can see that Prolog is fantastic at representing one of these is a transformation of one of those. And when you can represent things like that there's a simple mapping between things that is declarative, A relates to B, then programs become easier to understand. And when they become easier to understand, they become easier to write and maintain. And one of the things we have discovered at Similarity is that our Prolog code is the code that has the least amount of bugs and that people can pick up and start working on the quickest. And it's because of declarative syntax. Now, kind of the last step here, and I promise I won't talk, I think I'm over time a little bit here, but I promise I won't talk much longer, is how we fix the shortcomings. And criticisms of Prolog and its efficiency often leave out the benefits of Hummel Iconicity, and that Hummel Iconicity is the main reason for the inefficiency. And one, the efficiency thing could be fixed by implementations in other programming languages, where you simply write the things that are inefficient in Java or C or C++ or so forth. And but unfortunately, Hummel Iconicity can interfere with this. And the reason why is that Prolog terms have to be representable in the foreign language, and all parameters to a predicate must be terms. And so in that foreign language, I have to have something that connects the representation of in the internal representation of a term in the Prolog implementation with the representation of a term in the foreign language. This is different for every implementation of Prolog. There's almost no overlap here. Learning one Prolog and being able to connect it to one foreign language tells you almost nothing about how to connect it to another foreign language or with another implementation of Prolog. And some convergence on this subject would be good. It's probably not going to happen. At Similarity, we try to interface Prolog with Java, and a number of Prologs interface with Java. There are some things you need to understand before you do this in a commercial environment. One, 2Prolog is a native JVM implementation, and it has facilities for implementing native Prolog predicates in any JVM language. Terms are represented as a class in a plain old Java object, and so if you have to interface with the JVM or JVM languages, it is a good choice. Its license is a little bit problematic. It's licensed with the LGPL, and so while it is appropriate for some commercial program implementation, check with your lawyer and make sure it doesn't interact with anything if you use 2Prolog. SWI-Prolog uses JPL to interface with Java. And SWI-Prolog has a more friendly license to commercial users, but it has some issues. And what that issue largely is, and this is a repeating theme, and if you're going to use Prolog in a commercial environment, this is the biggest thing you have to worry about, and this is my last point, I promise. And that is that when you have to find libraries and things like this, the LD library path needs to be set up correctly on your Unix machine for it to find the actual shared object file that implements it. And in most Linux implementations of SWI-Prolog, that is broken, and you need to go into the LD config. You need to config ld.so to find the SWI-Prolog JNI libraries for JPL, or you will get errors when it tries to use JPL. If that could be fixed, SWI-Prolog would be probably the perfect language to interact with the JVM with. But that is a serious problem. When we install our software, we actually have to go in and doctor the ld.so configuration so that it can find the right libraries. It's very tuned to specific versions of SWI-Prolog and specific versions of Ubuntu. So this is a little hairy. And if one of you programmers out there can figure out a way to resolve this issue, everyone will love you. And that is that every distro wants to install it in a different place, and then when you run the executable, it doesn't work because no one tested it with JPL. Okay, that reaches the end of my presentation here, and I only went a few minutes over, and we're ready for some questions.
Yep, we're ready for questions, folks. There'll be a little delay while.
Here.
There'll be a little delay while.
Okay.
Yeah, and okay. I have a comment. The LD.so problem sounds like it.
Yes, and that's what we do. Well, typically, when we distribute with our customers who use the satellite image product, it's all built into a Docker image that does it exactly. I would like to be able to solve it without Docker, but you're absolutely right. Docker is an effective solution. Back. Oh, can you not hear me, Annie?
I'm back. You're back.
Okay, what I was just saying was that we do use that Docker technique to solve the LD.so problem, and we would like to have other solutions that work better, but the participant who noted that really understands the problem.
Okay.
Because Docker is an effective solution.
Yeah. If I understand correctly, other than the fact that every Prolog implements its own distinct SWI, I get the impression that in any one Prolog, why is it so hard to interface Prolog with other languages?
The main reason for it's difficult to represent Prolog with other languages is that the function call interface of Prolog, the predicate call interface, is a generalization of a procedure call, and in that generalization, it takes Prolog variables which can be free or bound, and Prolog types. There's exactly one type in Prolog, the term. So every parameter to a function must be represented as something which can represent a term which is either bound or free, and represents the and can represent any Prolog term. There's a lot of ways of doing this, and what I suggest everyone do is briefly look over the FFI documentation in SWI-Prolog, and then go to GNU Prolog and look at their FFI implementation. They are completely different, and they could not be more different. And some Prolog related languages like Mercury solve this problem by having a mode and type system. that represents how predicates can be called, which then allows you to make more assumptions about the implementation. If I know which variables have to be boundary free as they go in, I can simplify the implementation a little. But in a general purpose Prolog implementation, it's the generalization of predicate calls and the Hummel Iconicity, the fact that every Prolog element is a term, that makes this difficult to reify in terms of other programming languages. I have to have some complex data structure to represent the term.
And a follow-up question, and I'm tempted to. Why is there no standard that all Prolog implementations follow?
I can answer that question. Prolog was invented in 1972 by a French professor named, and I'm going to pronounce this horribly wrong, Alain Colmerer. And at that time, standardization of programming languages was not something that happened. Programming languages were written to run on specific pieces of hardware, and that's it. I am not so old that I actually remember programming in 1973. I was 8 years old in 1973. But at that time, the idea that a programming language would have a standardized environment hadn't been thought of. It's not until Ada comes out in 1983 that the trick of trademarking the name of the language came about, so that people could only call it Ada if it passed a suite of tests. This was reiterated by Java, that you can only call a programming language Java if it passes the Java tests. And so modern programming languages, which are either from a single source like Ruby and Python, or have trademarked names like Ada and Java, these allow you to fix an implementation. There's an ISO standard for Prolog, which was adopted, about 20 years ago, Annie? 15? It was a while back, 15 years ago at a minimum. But and many Prologs adhere to the ISO standard to some extent or another. But there's not any commercial drive for this to happen. Prolog is not used enough commercially to have anyone motivated to go through the work of unifying Prolog implementations or establishing some standard that everyone strove to adhere to.
As somebody who works kind of more on SWI-Prolog, it's kind of in the nature of Prolog. Prolog is a language which is Hummel Iconicity, modifying your own code, introspecting your code, and mess with it. In fact, we're going to have a week of class, the 7th week, that I've titled Semantic Plasticity, and we'll do a bunch of that, and that really is in opposition to standardizing sometimes, because most programming languages, I don't think it is normal that most of their libraries are submitted. That is normal for us. I would probably a good half of all project, and similarly for things that come into core. At the moment, it's actually many things are coming into core from cutting edge things. Super informative presentation. Thanks very much. And we have other questions before we go? Okay, I think we're... All right, so I think we're um, thank you all very much for coming. Thank you, Ray, for giving this. This has been wonderful. Uh,
Thank you,
and
Andy, for giving me this opportunity. I love evangelizing Prolog.
well, thank you. Okay, and with that, folks, we're back and on the Moodle, and